Greeting, ladies and gentlemen. My name is Nimson Hoa. I am a sophomore at Paragon International University of Cambodia. Today, I am proudly present to you my very own research assignment that was assigned by Professor Lê Minh Liang in course Engineering Dynamic. The topic that I'm gonna present to you is about Burj Khalifa aerodynamic resistance. Let's do it. And before we take a look at Burj Khalifa, we need to know the history of uh, tall building. So this is in a way in the year of uh, the 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 tall building from the in the 21st century. So it starts from less more than 300 meter and go all the way up to 800 meter in the Burj Khalifa. And Burj Khalifa is still completed in 2010, was still the tallest building in. So Burj Khalifa is in Dubai, United Arab Emirates. This country, if you don't know, is located in the Middle East, border with the Persian Gulf, the Saudi Arabia, and the country of Oman. So this is the flag of the United Arab Emirates. Many of you would recognize this city and country from the movie Fast and Furious, the seven, when they go to the desert and do a high steel a supercar jumping from building to building. And obviously, if you watch Formula One, it is um, the finale race in the desert of Formula One season. So Burj Khalifa, it is estimated to be 830 meter tall, costing approximately $1.5 billion. The building was designed by Mr. Adrian Smith, who is this guy. He is a very famous American architecture who built many famous famous project, and it was constructed by Samsung Construction Group. So Burj Khalifa, as you know, is they use the tube design, which is a design of the Willis Tower in Chicago, in America. And the design of the building also derived from the spiral pattern in the Muslim design, which is in Islamic architecture. So as the tower rises from the flat desert base, it has a setback. So it has a setback and decrease in cross-section spiral from the bottom to the top slender. And Yeah, this is they follow the tower of the Mars pattern, and after the completion of the Burj Khalifa, it achieved many record record such as the world tallest tower in the world, tallest skyscraper, the world highest elevator. It is three time the height of an Eiffel Tower, and it is mostly very excitingly if you want to enjoy a good nightlife. It is world tallest uh, the world tallest bar, which is at the 144th floor, and it has a lot of floor. It achievement. So when engineer want to build something this high, they have a high ambition. There is always a drawback, a problem, and a challenge. So most typical um, load that is common when building a skyscraper is called wind load. Wind load is very important that when they consider building a skyscraper, it can cause the building to bend, to move, or flex. And the taller the building go, the stronger the load progress. And this load is not a very good sign for the building because it can cause the building to have a bad to to flex so much that it is make the structure to fail. And this is how the wind works. So when the wind fly by, it will have a high pressure zone and a low pressure zone, and this can cause a phenomenon called vortex, which can cause the building to sway. It's like, and this is how it works. This phenomenon is like when a water causing a ship to sway. Building it will make the building sway, which cause the person or the people or the resident inside the building to have motion sickness, which is not good for the resident when they are in a skyscraper. So in Burj Khalifa, wind can go up to 240 and go up to 240 kilometer per hour. During a sandstorm, it can get even worse. So when building Burj Khalifa, it is very important to notify about this load, or there will be serious consequence. As an example, at the Tacoma Bridge, the wind load can be a resonator, which can resonate with the natural frequency of the Tacoma Bridge, which caused the building to collapse. Even at this accident, the wind was relatively not strong, but it resonated with the sway of the bridge, causing it to sway violently, and uh, at the end, it fell. Structure fell. So when engineers want to build a building, they don't want this to happen. So engineer, as you know, are a profession who invent, design, and build machine complex system to fulfill the function objective requirements. So they have to come up with a solution. So the goal of the engineer, they need to fix this problem. So to do this, they want to analyze it. Uh, the wind is caused by, as we know, the phenomenon called vortex shedding. So the engineer, uh, using very innovative approach, they come up with a variety of solutions. So the first solution is corner softening. This is very simplistic way to reduce the wind load. So by reducing the corner, making it not like a brick, not like a bar. They just make the corner slender, like a a surface of a sphere, or even a curve. They can make the air not hit the building hard, so there is less pressure on the building. There is another way. Next is the reduction of width. This is uh, most of the time, this is a very simple approach, and it is very common when building a skyscraper. As you can see in the New York Manhattan, you see that most building is very wide at the bottom, and as they go to the top, they slender the width down, narrow it down to an antenna. With this approach, they can uh, alter the wind. They can alter the wind to not very to have less load at the top, which is the place where it can cause the moment or the bending uh, to the building superstructure. And finally, they can use the approach called curving the building. This is kind of similar to corner softening, but they curve the building totally, and they make it curve to the wind like the Shanghai Tower. They curve the building like a spiral, which make the wind flow through the building smoothly with no turbulence like a laminar flow. And there's other simple way like using a damper or many more, but this is three is the most useful approach to the skyscraper problem. So for Burj Khalifa approach, they use curving to sway the wing. So what I mean is that from further view, you can see that the building is like Willis Tower. It's like multiple setback, and it doesn't look like curve at all. But taking a closer look, doing more inspection, you can see that it is very curved. Um, so it tried to eliminate the phenomenon called vortex shedding. So for a building of this height and slenderness, wind force and the resulting motion is very dominant factor. So building and designing this massive project as Burj Khalifa, they need a lot of precise data in order to eliminate the vortex very efficiently. So they built a small scale of the building and put it inside a wind tunnel, and doing a test approximately about 40 times, ranging from low speed wind to high speed wind, which represent a normal day of wind to a very disaster wind such as the sandstorm. So so with this enough data, engineer come up with a solution to reduce bias. I told you to curve the pattern. It's improved the outer buttress, and obviously there are many ways that they can curve the building. So they use the most effective one, which is a round shape, and with enough round shape of the building, the building become curved and slender, which have prevailed the wind load. As you can see, there is no more vortex shedding. It's just the wind just flow nicely, like a laminar flow, if you know it, no turbulence. And with this oriented of the shape, it have reduced the swaying of the building, which have reduced motion sickness of the residential. So with this, engineer use another simulation to test it. Finally, they use a simulation called SimScale to do that, and they see that, as you can see, there is less pressure load at the back of the building, which is a nice thing to see. You don't want to see that. So there's no vortex shedding, and it's just very nice. A nice concept, a nice solution to it. So this is the end of the presentation. So thank you very much, and I am really sorry if I make a lot of mistake or I am nervous. This is my first time record a video, so hopefully you like this video, you can leave a like or dislike. It's okay. I don't mind. And if you have any question, you can comment or you can email me, or I will leave the reference in the description below. And yeah, this is the end of the assignment. It's nice that you listen and you follow all the way through. Thank you very much. Don't forget to click like. Thank you.